while this is the shell, that is the bulk model of arrangement. In this situation, if you want to know the block to which this element belongs, we go to the last orbital. Which one is the last orbital? 4s. What is the electron on it? 2. So this one will definitely show that calcium will definitely belong to the s block, because the last electron is on the s orbital. That has explained the groups and periods, because elements are placed in group based on the outermost or valence electron, while elements are placed in period based on the number of shells. In that situation, sodium is in group 1 because it has only one valence electron, while calcium is in group 2 because it has 2 valence electrons. Elements are placed in period based on the number of shells. Consequently, sodium is in period 3 because it has 3 shells, and group 1 because it has only one valence electron. Blocks of elements. A block of the periodic table of elements is a set of adjacent groups. There are 4 categories, namely S block. They are the first 2 groups of the periodic table, that is, the alkali metals and the alkali earth metals. The alkali metals are simply the group 1A elements. Examples, we have sodium, potassium. Then the alkali earth metals, these are the group 2A elements. Example, calcium, magnesium, etc. P block, they include all the non-metals except hydrogen and helium, simply because hydrogen is placed in group 1, not just because of the fact that it is a true alkali metal, because it has only one electron in the outermost shell, and in that situation it will not readily lose it, rather it will prefer to share it. Helium, on the other hand, helium is a noble gas because it attains the duplet configuration because of the fact that it is very stable. In that situation, it does not react. So that is why it is not a p block element. They are called because they contain the p electrons. Then the D block. The D block, they are the transition elements. They are also called because they contain the D electrons. And these are elements between 21 and 30. Then the F block, they are the lanthanides and actinides. They are so called because they contain F electrons. Metals, non-metals, and metalloids. What are metals? Metals are elements that donate electrons to become positively charged. Example, sodium. Example, sodium. Sodium is a metal simply because it is, by Bohr model, it is 281. It has 11 as the atomic number. So when it loses this one electron, it becomes Na plus, and that is 28. So this sodium is what is known as, it's an example of metal. Another example is calcium, etc. Non-metals. Non-metals are elements that accept electron to become negatively charged. Examples, oxygen and chlorine. We have so many other ones too. You have your sulfur and the likes. The metalloids. What are metalloids? Metalloids are elements on the dividing line between metals and non-metals. What do we mean by dividing line? That means they share both the characteristics of metal and the characteristics of non-metals. They are also called the semi-metals. Examples are silicon, germanium, etc. Transition metals. They are the metals that have partially filled d orbitals or contain d electrons. Example, scandium. Scandium is 21. Scandium is 21. Then for scandium, you have the argon field. Argon field, then 4s2, 3d1. 4s2, 3d1. What is meant by this argon field? You don't need to confuse yourself. It assumes the electron configuration of argon. So, and that means for argon field, you have 1s2, 2s2, 2p6, 3s2, 3p6. So if you sum all these electrons, you discover that there will be 18, and argon is 18. So instead of going through the rigor of writing this argon electron configuration, we can just shorten it as argon field. Then this, instead of writing this together with this, I can now write the whole of this as argon. Then 4s2 3d1. So this is the first member of the transition element. We have so many of them too. We have our ion, which is demonstrated on the slide, and so many others. Transition metals are conformed to argon field 4s2 3dn. Conform to 4s2 3dn. That means you have your argon field, then 4s2 3dn, where n is the number of electrons. Families of elements. Elements in the same group are family because they show similar chemical properties. Examples: lithium, sodium, potassium are families. Then fluorine, chlorine, bromine, and iodine are family, and they are all called halogen. SPDF notation. The concept of this notation is made elaborate by wave mechanism model, where s orbital has one suborbital, p orbital has 3 suborbitals, d orbital has 5 suborbitals, while f orbital has 7 suborbitals. The modern way of writing electron configuration using wave mechanism model is given below. And for lithium, you have 1s2, 2s1. For sodium, you have 1s2, 2s2, 2p6, 3s1. Group A elements and their properties. They are elements that have only one valence electron. The familiar elements in this group are sodium and potassium. They are univalent, that is, each of their atoms has only one valence electron. They ionize very readily to form positive ions by donating electrons to form electrovalent compounds. What are electrovalent compounds? Electrovalent compounds or electrovalent combination is the process whereby you have an interplay between a metal and a non-metal, and what the metal is doing is to transfer electron to what? The non-metals, while the non-metal is the receiver. So the interplay between metal being transferred electrons and the non-metals being received the electron. That is what is the brainwave behind electrovalent combination. They are very good conductors of electricity, and they conduct electricity by mobile ions. Take note of that. They conduct electricity by what? Mobile ions. That means they need to dissolve in solution and they break into ions, and that aids their conduction of electricity. They react with cold water vigorously to liberate hydrogen gas and form alkalis. That is one of the properties of group 1A elements. Alkali is a basic hydroxide that is soluble in water. Example, sodium hydroxide. And on the slide, you can see how sodium, 2 moles of sodium in the solid state, reacting with 2 moles of water in the liquid state to form 2 moles of sodium hydroxide in the solid state plus H2 gas, that's gas. So in that situation, sodium reacts with water to form an alkali, and in the process liberates hydrogen gas. This is the reason group 1 elements are known as alkali metal, because of their ability to react with water to form an alkali, which has been established as basic hydroxide. Group 2A elements and their properties. The group 2A elements are elements with 2 valence electrons. Familiar elements in this group are magnesium and calcium. They are divalent elements since each of their atoms has 2 valence electrons. Each of the atoms has 2 valence electrons. And common reactions. Calcium in the solid state reacting with 2 moles of water in the liquid state. This time around, give calcium hydroxide, aqueous, plus hydrogen gas. Similar reaction is also possible with magnesium, but the difference between calcium and magnesium in their reaction with water is that in the case of calcium, When it reacts with water, you have a basic hydroxide being formed, that is calcium hydroxide, what is known as slaked lime. While in the case where magnesium reacts with water, you have magnesium oxide. In this situation, it forms a base but not an alkali. Both of them will liberate hydrogen gas. But the difference between their reaction is that calcium reacts to form basic hydroxide, which is calcium hydroxide, while magnesium reacts with water to form magnesium oxide. Properties of elements in the periodic table. 1, you have ionic size. This is a measure of the size of the ion. How does it respond across the period and down the group? Across the period, it decreases across the period due to an increase in nuclear charge. So what is meant by increase in nuclear charge? You know, as you move across the period, electrons are being added. And as electrons are being added, protons are being added simultaneously. So in that situation, as you continue to add protons to the nucleus becomes bigger. And as the nucleus becomes bigger, the size or the distance between the valence electron and the nucleus become closer. And in that situation, the size will be affected. That is, the size decreases. And that is why ionic size decreases across the period due to an increase in nuclear charge. Then down the group, as you move down the group, it increases down the group due to increase in atomic number, which corresponds to increase in the size of the atom. So as you are coming down the group, what happens is that there is increase in atomic number. And that is why you have your lithium. You have your lithium, sodium, potassium. Lithium is 2, 1, 3. Atomic number is 3. While sodium is 11, that's 2, 8, 1. While potassium is 19, 2, 8, 8, 1. What can we experience down the group here? What we can